Welcome. In this video, we will explore the world of regular expression performance benchmarking. We will focus on testing and comparing the performance of different regular expressions. Key points in this video include performance optimization techniques and benchmarking methodologies and tools. By the end of this video, you will have a solid understanding of how to measure and improve the performance of your regular expressions. Let's discuss why regular expression performance is so important. Firstly, application speed is directly affected. A faster regular expression leads to more responsive applications. Secondly, resource costs are also a major factor. Efficient patterns reduce central processing unit usage, which in turn lowers operational expenses. So, optimizing regular expressions not only improves speed but also saves you money. Here's a basic example of how you can set up benchmarking in Python. First, import the time and modules. Then, define your regular expression pattern and the text you want to search within. Record the start time, run the regular expression search multiple times in a loop, and then record the end time. Finally, calculate the time taken and print the result. This gives you a simple way to measure how long a regular expression takes to execute. Let's explore some tools available for performance testing. The first one is the timeit module. This is Python's built-in timing utility. It provides precise microsecond measurements, which are essential for accurate benchmarking. Another great tool is pytest-benchmark. This is an advanced benchmarking framework. It offers statistical analysis and reporting, giving you a more comprehensive view of your regular expression performance. Here's a comparison between an inefficient and an optimized regular expression pattern. The inefficient pattern on the left uses nested quantifiers, which can lead to excessive backtracking and slow performance. On the right, the optimized pattern uses atomic grouping, which avoids backtracking and results in faster performance. Even though both patterns achieve the same result, the optimized version is significantly quicker. Let's see how you can create a benchmark test suite. First, define a function called benchmark patterns that takes a dictionary of patterns and a text as input. Compile each regular expression pattern once using re.compile. Then, for each pattern, record the start time, run the findAll method multiple times, and calculate the time taken. Finally, return the results as a dictionary. This function allows you to test multiple patterns against the same text and compare their performance. Let's discuss the key factors that affect regular expression performance. First, pattern complexity plays a significant role. It is important to avoid nested quantifiers, which can lead to backtracking. Also, minimize backtracking as much as possible to keep the regular expression efficient. Secondly, the input data size also matters. Consider how text length impacts performance and how memory usage scales with larger inputs. Here's a summary of the best practices to keep in mind. Things you should do include compiling patterns once for reuse, using specific anchors to limit the search scope, and testing with real data to ensure accuracy. Things you should avoid include nested quantifiers, excessive backtracking, and overly complex patterns that are hard to optimize. By following these guidelines, you can write more efficient regular expressions. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.